Alright, we are told assume that that's part D, assume that a 97% confidence interval estimate of the population mean monthly salary for accounting graduates. Remember, accounting is desired. Alright, so we're given the desired margin of error here. How large a sample should be taken? So we are looking for sample size. So I'm not going to, again, like I said, for detailed explanation of how the formula comes about, please subscribe to the videos. But for now, I will just use the formula as it is. So your formula for finding the sample size is n equals to z alpha over 2 squared times standard deviation squared divided by e squared. So remember, your E is your desired margin of error, so your E, desired margin of error. Your Z alpha over 2, it will be based on your confidence level. Just say based on confidence percentage, and your sigma is your standard deviation. Alright, so it seems like everything is there for us. We just have to write them down. So in our case, our desired margin of error is 450, which is this one. 450, and then our Z alpha over 2 is based on 97%. So how do we find that? So it's very simple, but it depends on which table you are using for your normal distribution. So like I said, the tables, there are 3 different types. So you will find a table like this, which will be giving you values from 0 to Z. You'll find also a table like this, which will be giving you only this side, and you also find a table like this, which will be giving you values covering this whole side. So depending on which table, it will show you, I'll show you how to calculate the value of Z alpha over 2 based on 97%. Alright, so if we are using this first table, alright, it is going to be very simple. You just come and take your percentage, 97%, convert it into a decimal, which is 0.97. Therefore, your Z alpha over 2, you just come and divide 0.97 divided by 2, which will give you 0.97 divided by 2. I get 0.485. 0.485. Alright, now what we are going to do is simply to go to the normal table, which looks like this, the one which is half, and then look for 0.485 inside the table, not by looking on top and bottom to find where they link. We're going inside and look on all those numbers, which one is 0.485 or as close to 485 as possible. Okay, right, so let's do that. So remember, we said we want to use this particular, this is the shape that I was talking about, from 0 to Z. Alright, so we want 0.485 inside the table here. 485, 483, 487, 486, 485. So as you can see, 0.485 is right here. Now, it corresponds to which number? It corresponds to 2.1, and on top here 7, 0.7. So in other words, it's 2.17. So it corresponds to 2.17. Okay, 2.1 on this side and 7 on this side. So it's 2.17. That's what we are looking for. So once we have that, we know our Z equals to 2.17. Alright, we can do, remember we don't have to do this with all three. I'm just illustrating for you that depending on what table you get in your exam, you should be able to get the value correctly. So assume we are given this second table in our exam. How do we get this 2.17? Alright, so it's the same way. Here we will have 97%. Let's say the red one, so it will be 97%, which is again 0.97. But now, since we're using the smaller version, the one which is shaded small, what you simply do is you come and say 1 minus 0.97, and the answer you get you divide by 2, and then we look for, we see what we get. 1 minus 0.97 divided by 2, 0.015. So 0.015. So again, we go to a table which has a smaller tail and we look for 0.015 inside the table. Alright, so let's do that. Let's see if we will find the same answer. Alright, so as you can see, this is not the table we want. We want this table. As you can see, there is like a smaller tail that we're talking about. So let's look for 0.015. So we want to just 0.0, 0.017, 13, 158, 154, 15. There it is. As you can see, this is 0.015, and it corresponds to there and there. So it's 2.17. Do not worry about the negative side because it's on the negative side. If this shading was on this side, the answer will be positive. So just ignore the negative. So again, as you can see, we find our 2.17. Okay, so again, even if we use the other methods, we will start 97% equals 0.97. Now when you're using the cumulative one, the one which is positive, what you simply do is you come and take 0.5 and then you add to 0.97. 0.97 divided by 2. Alright, let's see what we get. 0.5 plus, then we have our 0.97 divided by 2. So you get 0.985. 0.985. So we go in a table which is cumulative positive and look for 0.985 and see what value of Z we will get. So is this our table? Let's make sure. Alright, as you can see, this is the cumulative positive. So we're going to look for 0.985, 98, 987, 987, 984, 989, 985. There you are. As you can see, it corresponds to 2.1 and 7 this side. So again, you get your same answers as everywhere else. So we know Z alpha over 2 equals to 2.17. Alright, so remember I said you didn't need to do all three. I just did all three to illustrate for you a point. So now we have our Z alpha over 2, which is 2.17. Then our standard deviation, remember, for accounting graduates, they said accounting graduates. So for accounting graduates, we know it's 6,000. Is it true? We can just go back to our original question. For accounting graduates, assume the probability monthly salary deviation, standard deviation for the accounting is 6,000. So we're sure it's 6,000. So once you have all of those things, you simply come and put them in the formula. So to get your n, you're going to just have 2.17 squared times 6,000 squared divided by 450 squared. Right. Let's put that in our calculator, guys. Our savior here, squared times 6,000 squared divided by 450 squared. There you go. Get 837.13. 837.13. Now, the important thing when you're looking for the sample size, always take the next whole number. It doesn't matter whether it's, when you round it off, there's a 1, just take the next number. So 837.1, it means the next number is 838. That's the next integer. So our final answer is, which is equal to 838. Done. So how large a sample should be taken? So it should be 838. So that's how we do question D. Sorry for making it long, because I had to illustrate the 3 different ways to do it in terms of getting your Z alpha over 2, because as you can see from this question, getting the Z alpha over 2 is the only challenge. So when you are dealing with the obvious numbers like 95% confidence, 90% and 99%, it's easy because you can memorize them. But when you are dealing with odd numbers like 97, 98, 91, whatever they will give you, you should be able to know how to calculate the Z alpha over 2. So see you in part E, and ciao for now.